There it is. Hi, how's it going?
Not very well. It's about that disk drive you fixed. Seems it wasn't fixed correctly, and it's become a pretty costly error.
Well, I thought it was a leaking
I thought about it, and I realized you've never been properly trained on taking and reading measurements on the Fluke 77. Well, I just spoke to the electronics instructor over at the community college. He said it'd be fine for you to come over for a few hours, and he'll show you the features and functions of it.
Well, great, I'll be there.
Good.
Morning. Morning. You must be Jerry.
Yes, Dave.
Good to meet you.
Nice
Have a
to meet
seat.
you. Okay.
I've just been setting up here for us to take some measurements. I thought we'd start with power supply and then review some of the basic features of the Fluke 70 series meters. We'll be using the 77.
Okay.
First, for all of the meter functions, we want to plug the black lead into the common jack. Now, for voltage, resistance, and diode measurements, we want to plug the red lead into the jack marked with voltage, ohms, and diode symbols. You know, these two terminals are protected against overload voltages up to 1,000 volts DC or 750 volts AC when the meter is being used for voltage measurements. Okay, now we're ready to turn the meter on. So since we're taking a DC measurement, we turn the rotary switch to volts DC.
Now, what does this display mean?
Well, whenever the meter is powered up, it does a brief power-on self-test. It's checking the operation of its own circuits. When the test is completed, the meter chirps to indicate that it's ready for use. The 77 also powers up in the auto range mode. It'll automatically select a measurement range that will provide the best display resolution for the value that's being measured. The resolution is the degree to which small changes in measurement can be identified. So, if we take a measurement of 12 volts, the meter will automatically choose its 0 to 32 volt range and display the voltage with 4 digits. Another useful feature is the analog display. It's updated 25 times per second, while the digital display is updated only 2.3 times per second. Now, this means that the analog display settles 10 times faster than the digital display.
Where would you use that feature?
Well, Jerry, since the analog display moves so quickly, it can be used like the needle on an analog meter for observing changing values of voltage, current, or resistance. Now, back to measuring DC voltages. To take an accurate reading of small DC voltages, we should turn the dial to the 300 millivolt DC function.
So that would set the meter to the 0 to 320 millivolt range.
Yes, for both the analog and the digital functions. In this range, the volts DC label no longer appears, and the resolution is increased to 1/10 of a millivolt. So, with the switch turned to the 300 millivolt, this measures 83.6 millivolts. And if we switch to volts DC, the reading should be
0.083.
Right.
Now, does the 300 millivolt function auto range?
Well, no. Voltages above 0.32 volts would produce an overload reading, at which point, well, we'd have to return to the volts DC setting. Moving on to AC measurements. Digital multimeters will give accurate AC measurements only when the frequency of the AC voltage is within a certain range.
That's called the bandwidth.
Right. And the 77 will accurately measure AC sine wave voltages up to 320 volts RMS if the frequency of the AC voltage is between 45 hertz and 1 kilohertz. For sine wave voltages between 320 and 750 volts RMS, the bandwidth of the meter is 45 to 500 hertz. It's important to know the bandwidth of the meter we're using, because if we're trying to measure something above or below that range, we could get an inaccurate reading. So, to measure AC voltages up to 750 volts, turn the rotary switch to volts AC. And the reading is 7 volts. Now, we'll use this simple resistor circuit to take some current measurements. There are a couple of issues, though, that we need to keep in mind before taking any measurements. The first one is that the 70 series is not designed to be used in high-energy environments. That is, in circuits above 4,000 volt amperes. The second is that because a current meter acts like a short, the meter must be put in series with the circuit being tested. Excessive current through the short may result in damage to the circuit under test or the power supply of the circuit. Before we take a current measurement, the red test lead has to be moved to one of the two current jacks on the meter.
Why is that?
Well, because if I forgot to move the red lead to one of the current jacks, I wouldn't get a valid current reading because the measured current wouldn't be flowing through the correct circuits inside the meter. First, we'll take a measurement of less than 320 milliamps. So we'll plug the lead into the 300 milliamp jack. Now, the direct lines connecting the common jack and the current jacks on the front of the meter indicate a direct connection, or almost no resistance between the jacks. Now, as I said, the meter needs to be put in series with the circuit being tested. Now, this means that we need to make an open in the circuit and then use the meter to bridge the open.
Oh, so if I put the current meter across a component, I would short the component out.
Right. Since a current meter has almost no resistance, it will act like a low resistance wire when placed in series with a circuit. The 300 milliamp current jack on the meter is fuse protected against overloads.
So if I forget to put the meter in series, I might blow the fuse.
Correct. To measure DC currents between 320 milliamps and 10 amps, we use the 10 amp jack. Current measurements taken through this jack are displayed in amps, so 210 milliamps are shown as 0.21 amps when measured through this jack. AC current measurements are made by selecting the amps AC function. Now, the procedures for measuring DC and AC current are much the same.
What type of circuit can I use the 10 amp range on?
It's a good question. To prevent damage to ourselves and the meter, it shouldn't be used in circuits above 4,000 volt amperes. Now, let's move on to resistance measurements. To make resistance measurements, we select the ohms function. Now, the 70 series can measure resistance from 0 ohms to 32 mega ohms. Because this is a mock-up, I don't have any power going to it. But in a circuit, we have to be sure the circuit's power is turned off. If voltage were present, the meter would give erroneous readings. So when we put the leads across the resistor, we get a reading of 12.8. I have to be careful with this and other measurements to keep my fingers off of the metal portion of the leads, because the resistance of my body would be in parallel with the resistance of the component, resulting in an incorrect measurement of the component's resistance. As you can see, the unit of the measured resistance, ohms, kiloohms, or megohms, is given automatically on the display. Now, for resistance above 32 megohms, the meter will display overload. Now let's go over the diode function. We can test the diode in or out of the circuit. I have to be sure the circuit power is off or the diode test won't work properly. So to check the diode, we put the black probe on the cathode and the red probe on the anode. Now the meter is indicating the forward bias voltage drop across the diode.
What is the drop of a good diode?
Well, good silicon diodes generally drop 0.5 to 0.8 volts, depending on how they're manufactured. Since most good diodes will drop less than 0.7 volts, the 77 has a beeper that will beep once when the diode's voltage is below 0.7 volts and will give a continuous tone for shorted diodes.
Oh, that would be great to check diodes in a circuit without having to look at the meter's display. And I could use the continuous tone to check continuity when it isn't convenient to look at the meter's display while taking a measurement.
Very good. Very good. Now, if I were to switch the leads to the reverse bias condition, the reading of a good diode would vary depending on the values of resistance that may be in parallel with the diode in the circuit. For the 77, I can generally assume a diode is good if the forward bias test produces a beep and the reverse bias test doesn't. Diodes that are open will give an overload reading in both forward and reverse bias conditions if there are no other components in parallel with the diode. If an open diode has some resistance in parallel with it, then we would get the same voltage reading in both forward and reverse bias conditions. The value of the voltage reading depends on the value of resistance that is in parallel with the diode. If the diode is shorted, the meter will display a low voltage in both forward and reverse bias conditions. This low voltage is usually less than 0.1 volts. Well, let's talk about a feature that can override the auto range mode, called range hold. Now, this feature allows me to set the meter into a fixed measurement range. Range hold can't be used with the 300 millivolt DC or diode check. To activate range hold for any other function, I press the range hold button. Now, this holds the meter in the measurement range that the meter's in. So, we selected volts DC function, and since no voltage is being measured, the meter's auto range function has selected the 0 to 3.2 volt range. So, if I wanted to take a series of measurements in this range, I would touch the range hold button. Now you see, the range hold symbol has appeared on the display. Now, since the meter is now set in the 3.2 volt range, any voltage measurement above 3.2 volts will result in an overload reading. Now, to select the next highest range, I press the button again. Now, the meter is in the 32 volt range now. A chart that gives the ranges for ohms, volts, and amps functions can be found in the operator's manual. To return to the auto range mode, I press the range button until the range hold symbol disappears. Now, the last feature that I'd like to talk about is touch hold. Now, this feature applies to the 77 and several other Fluke meters. When testing electronic equipment, there are often times when it's not easy to place the probes in the circuit and watch the meter's display at the same time. Touch hold allows me to capture the reading on the display when the leads touch the circuit or when I push the range button. To activate touch hold, I first turn the meter off. Now then, while pressing the range button, I turn the switch to any function. We'll use DC voltage. When the display segments appear clearly, I release the button. Now you see that the touch hold symbol appears on the display.
How long does it take to capture the reading?
Well, the measurement has to be constant for half a second, and then the meter will beep and capture the reading. Now, if the reading changes while the probes are in contact with the circuit, the meter will capture the new reading after it's been constant for at least half a second. A reading can also be captured by pressing the range hold switch when the touch hold is active like this. Well, I think that just about covers it. Obviously, there are many more applications than what we've covered here today, but I think now you have a pretty good foundation to work from.
Well, thank you very much for your time. I already feel a lot more comfortable with this meter.
Good.
Oh, hey, this is a great tool.
Oh, that's terrific, Jerry. Hey, listen, since you're doing so well with it, I wonder if you could take some time and show that new technician what you learned. He's not very familiar with the 77.
Sure.
Wonderful. Thanks.